Welcome to Sri Sathya Loka Seva Gurukulam. Today's topic is about applications of semiconductor devices. And the topic we are discussing today is more interesting. It is interesting for the reason, if you want to watch a wonderful movie, do you want to watch that movie in a roadside theater, or you want to watch it in a Dolby Atmos studio? Naturally, the answer is Dolby Atmos. What would be the reason? So, the quality is good. You will have an exceptional audio quality, video quality in it. But have you ever asked yourself how this quality is arrived at? So, naturally, electronics. What kind of electronics it is? It is digital electronics. The reason why we are getting an ultimate quality in audio and video is because of the components which are digitizing the information, or in other words I can say that they are processing the information in a digital way. Ones and zeros, high voltage and low voltage. You can name it in any way, or 0 volts and 5 volts. 5 volts represents logic 1, 0 volts represents logic 0. Like good thoughts and bad thoughts are not so good thoughts, right? If you say good thoughts as logic 1, not so good thoughts as logic 0, right? But there is a fundamental entity that we have to see in digital electronics, which is logic gate. What is normal gate? Why somebody have a gate as a barricade between two places, two geographical places? So, I want to send people one by one. For that, I require gate. Now, I am asking most interesting question to you. What is the gate inside the human body? Can you locate where is the gate inside human body? Sir, in human body there is electronics. Yes, it is there. This place. What is this place? Mind. Our mind resembles a logic gate. Why? Because what is happening at the gate? There are many people arriving at the gate, but this particular security person is sending only one person outside. In the same way, to our human brain also, there are many thoughts that comes here. But always we should take one at a time, right? That is called as common sense. That capacity of this mind is called as common sense. Today we interestingly relate this common sense aspect with the logic gate functionality. Now let us define this logic gate electronically. What is that? It takes more inputs, it delivers one output. Just like the gate takes many people and sends one after another. So here you see this. We have a first gate called as AND gate. We have some basic gates like AND gate, OR gate, NOT gate. These three are fundamental gates. That means common sense qualities of human brain. And the first one is called as AND gate. There is other name for this. This is an interview question for a competitive examination. What is the other name of AND gate? Coincidence gate. What is the other name of AND gate? Coincidence. When two things coincides, what happens? Your common sense should say. I'll ask one question to you that you have Seva, you have spirituality. Listen carefully. You have Seva happening at a place. You have spirituality also happening. Spiritual growth is also happening at a place. Won't you take that as a coincidence? Wonderful coincidence. There is a place where the Seva is happening to humanity, and also there is a spiritual inclination to the human being. Other than that, what is a better place in the world? So like that, if you have two inputs at a time to a gate, and if you get an output because of the combination of these two inputs, that is called as combinational circuit. And the fundamental entity is AND gate, because these two inputs are coincidental and you will get an output. What is coincidental? Here we have a truth table. Here this is 1, this is 1. Then only you will get output 1. That means you have spirituality, we have Seva. Then only the right human intellect flourishes, right? The right human being comes out. You can say, sir, your problem is input should be same. Then in this case also 0, 0. Then it is 0. Can't you call this as, can't you celebrate this 0? Nobody celebrates 0, right? It should be a hero here. Who is hero? 1 is the hero. So 0 is not celebrated, 1 is celebrated. 1 is the happening, good thought. 0 is not so good thought. So that means this AND gate is so clever. When only two good thoughts like Seva and spirituality comes together, then only you are declaring that particular human being as useful to the society, or at least to himself. So this coincidence is wonderful coincidence happening in electronics in the name of AND gate. Okay. Now that is how at a diode level they have, this is called as gate level implementation or low level implementation. See, you have only one thing here. The truth table says that when only both inputs are 1, the output will be 1. This is the basic property of AND gate. Now, you see the second one, OR gate. What is OR gate here? This is the other common sense aspect of the mind. Somebody has given you sweet in one hand, hot, of course, in the other hand. Can you take both of them at the same time? It's not possible, right? Your common sense says that no, either sweet first or hot first. That means there is a condition called as OR here. That means human mind, common sense is also giving an option for us that it is not always AND, it is there OR also, ORR. OR means here ORR. So here A or B, either A or B is 1. You see the truth table now. Either A or B, if it is 1. If both are 1, that's fine. Then definitely you will get the output. Say simplified. Like we have in our mythology, they say that when all other yugas you do more penance, tapas. Okay, in Kali Yuga, just one namaste is enough. So it has come down to that level, right? At least one of the input is 1, the output will be 1. So this is called as OR gate, inclusive OR gate. What is the other name here? Inclusive OR gate. If both are zeros, nobody can do anything. Both are zeros means the output is invariably 0. At least one input is 1, you will get it as 1 as output. So this is the low level implementation. That's not a problem, but this is interesting. In earlier slide also we have seen this. Instead of just mentioning in this way, truth table manner, they have used some switches here. Here is an electric bulb, there is a voltage. You see this? There are two paths so that the bulb can be glown. The voltage is applied here. If the switch A is closed, the energy goes, the bulb glows. It is not compulsory that the switch B is also should be closed. At least one is enough. At least one path is enough. If one is closed means truth table value is 1, then the bulb glows. Bulb is what? Output. You want to see the previous slide? You see this? This is a series connection of the switches. For example, if one is closed, is it enough? This is closed or this is open. This energy will not go this side. The bulb will not glow, right? If the bulb has to glow, that path should be complete. That means A should be on, B also should be on. A should be 1, B also should be 1, then only you will get the output. So that is how it is arranged here, right? So this is a wonderful way of learning the gates. Of course, these are the logical representations, symbols for these gates, AND gate and OR gate. And here we have NOT gate. This is further interesting. When you want to understand in terms of mind, this is called our inner consciousness, right? There is a wonderful thing to enjoy. Your mind says that yes, your senses says that yes, I want to go. Your consciousness, the quality of the mind says no, you should not go for it, right? Always this situation comes. That means here it is your senses, here this is your common sense, right? If it says go for it, it says don't go for it, it is not good for you. So that means it is always ulta. If this is 1, this is 0. If this is 0, this is 1. This particular property is called as inversion, right? The gate which is representing this inversion is called as NOT gate. Now you see this, A is 0, output is 1. If A is 1, output is 0. Here this is a low level implementation. This low level implementation is very, very simple to understand. Why? Because I want to explain this for you. How it is? It is a common emitter configuration we have seen in the previous video. The emitter is grounded, input is applied here, output is this. What is input is applied here? Input is applied with low level first and then comes high level. But phase reversal property is 180 degrees phase shift. If it is low level here, it should be high level according to common emitter configuration. That is what we told as phase shift. So, if it is starting with low level, the output starts with a high level. So, this is the basic property of common emitter configuration, which is making as a strong contender for low level implementation of NOT gate, right. So, this is how digital electronics is studied. And when it comes to this NAND gate, now we are going to see two interesting gates, NAND gate and an OR gate. They are universal gates. Universal gates means you can use these gates in a plug and play manner and you can do in any other circuit. For example, NAND, how you will get? NAND is nothing but NOT plus AND. NAND means what? NOT plus AND equals to NAND. So, this is NOT and this is AND. When you combine these two, what you will get? NAND. If you don't have this bubble, it is called as AND gate. If you have a bubble, this bubble indicates NOT. So, AND plus NOT, NAND. Now, let me not see this. 1, 1, 1. What is this truth table? This is AND gate truth table. For AND gate truth table, here I am connecting one NOT gate. Means what? 0 is input means 1 is output. 0 is input means 1 is output. 1 is input means 0 is output. Right? So, we are connecting back to back one AND and one NOT gate. So, let me explain NOR gate. NOR gate means, just say along with me, NOT plus OR is equal to NOR, correct? You see here, NOT plus OR. So, this is nothing but NOR, okay. Now, here there is a bubble. When it comes to the OR gate, you won't get the bubble. OR plus this bubble indicates NOT gate. Now, let us forget this. This truth table you see, any one input is 1, output is 1. This is what I told for OR gate, right? So, this is OR gate truth table. Connect one NOT in between, input is 0, output is reverse 1. Input is 1, output is reverse 0. Input is 1, output is reverse 0, right? You can ask me why this combination, sir? Because using this combination, you can design every other combinational circuit. So, that is why they are called as universal. Now, you see this. Using the NAND gate, how you will get the NOT gate? So, this is the NAND gate. I am adding these two inputs. Same input is applied. 1 is applied here, 1 is applied here. 1 is applied here, 1 is applied here. In NAND gate output, what you will get? 1, 1 are applied. Output will be 0. So, that means here what you will get? 0. If 1 you are giving, you are getting output as 0. So, how this is acting now? Like a NOT gate. So, NAND gate acting like a NOT gate when both inputs are tied. This is interesting, right? So, this is how using NAND gate you can design a NOT gate. Similarly, you see, using NAND gates back to back connected, you can get one AND gate. How it is possible? 1, 1 is applied. What is the output of this NAND gate? When 1, 1 is applied, 1, 1 is applied, output of NAND gate is 0, right? So, here what you are getting? 0. This 0 is applied both sides. Let us see in the NAND gate when both are zeros, what happens? When both are zeros, what is output? 1. When both are zeros, output is 1. So, that means when you are giving 1, 1 as input, the output is also coming as 1. Let us see where, in which gate it is available like this. When inputs both are 1, 1, output is also 1. Which gate it is? AND gate. That means using two NAND gates, here 2 NAND gates back to back connected, we are designing one AND gate. Similarly, you can use the NAND gates, 3 NAND gates, and you will get one OR gate. That is why these are called as universal gates, right? Thank you.